What if an object hurtling through our solar system at 200,000 kilometers per hour isn't a comet at all, but a nuclear-powered spacecraft testing how humans respond? Picture this. July 1st, 2025, a telescope in Chile captures something impossible. An interstellar visitor moving so fast it could circle Earth in under 8 minutes. They called it ATLAS. But from the moment it appeared, the numbers didn't add up. And what Harvard scientists are finding now has some whispering a word they almost never say out loud: artificial. Here's what makes 3I/ATLAS different from anything we've seen before. Most comets glow from behind. Ice turns to gas, creates a tail, always pointing away from the sun. Basic physics. But 3I/ATLAS glows from the front, like headlights cutting through darkness. If this were just reflected sunlight, it would need to be 20 kilometers wide, massive, the size of Manhattan Island. But Hubble and Webb measured it much smaller, just a few kilometers across. So where's the extra light coming from? When the Atlas telescope first detected this object, astronomers immediately noticed something wrong. The brightness measurements didn't match any known comet behavior. The spectral analysis showed water ice signatures, but the illumination pattern was completely unprecedented. Dr. David Jewett from UCLA, who has studied comets for decades, admitted the object was producing dust at rates between 6 and 60 kilograms per second. Normal for a comet, he argued. But even Jewett couldn't explain the forward-facing glow. Avi Loeb, Harvard's former astronomy chair, and the scientist who shocked the world by suggesting Oumuamua was alien technology, has a theory that changes everything. If the light we observe were only sunlight reflecting, 3I/ATLAS would need to be bigger than Manhattan Island. The brightness profile we're seeing is consistent with something producing its own illumination. This isn't just academic speculation. Loeb founded Harvard's Galileo project specifically to study objects like this, anomalous visitors that don't fit conventional models. His team has been analyzing the data, and their preliminary findings are unsettling. What are we really looking at? A 20-kilometer rock that statistically should only appear once every 10,000 years, or something much smaller, generating its own light. The implications are staggering because objects that power themselves aren't natural, they're built. But the mystery doesn't stop with the glow. When scientists plotted 3I/ATLAS's trajectory, they discovered something that defied all probability. 3I/ATLAS is traveling on a trajectory tilted just 5 degrees from the plane where Earth and all planets orbit. The probability of this happening by chance? 0.2%. Let that sink in. And it gets stranger. This object isn't just passing through, it's taking a tour. October 3rd, within 29 million kilometers of Mars. October 29th, closest approach to the Sun. Later, within 33 million kilometers of Jupiter. But here's what really has scientists questioning everything. During its closest approach to the Sun, the moment when a comet should be most active, Earth will be on the opposite side. We won't see it. Coincidence or design? Loeb calls it a reverse Oberth maneuver, a way for a spacecraft to slow down and potentially stay in our solar system, all while hiding from Earth's view in solar glare. If you were designing a probe to study our solar system while avoiding detection, this would be the perfect trajectory. Now let me explain how the astronomical establishment actually handles discoveries like this. When telescopes detect unusual objects, the data goes through carefully controlled channels. Discovery teams get exclusive access for months through embargo periods. Then comes peer review. where a small group of approved scientists decides what's valid. The public only learns what makes it through this filter, and the filter defaults to safe. So when a self-illuminating object appears following an impossibly precise trajectory, what do the institutions call it? A comet. Just another space rock. Nothing to see here. But here's what they don't tell you. If 3 I/ATLAS is generating 10 gigawatts of power, equivalent to several nuclear power plants, it would need either an enormous fuel supply or technology far beyond our understanding. David Jewett from UCLA insists it's natural, pointing to dust production rates that match cometary behavior. But he's measuring what we can see, not what might be hidden, because history shows us the pattern. Labels end stories, but anomalies remain. Who decides what you get to know, and how many impossible things have been quietly renamed? Over the next few months, the real tests begin. October 3rd, Mars orbiters might capture close-up images, our best chance to see what this object really is. The Mars Reconnaissance Orbiter, equipped with the high-resolution imaging science experiment, could potentially photograph 3 I/ATLAS at a resolution of just a few meters per pixel. If successful, these would be the first close-up images of any interstellar object's surface. October 29th, the James Webb Telescope will track its heat signature during perihelion. If it's artificial, the thermal readings will be unlike anything we've seen. Webb's infrared capabilities can detect temperature variations across the object's surface. A natural comet should show heating patterns consistent with solar warming. But if 3 I/ATLAS is artificially powered, the thermal signature would reveal internal heat sources. But here's the problem. During the critical perihelion passage, it vanishes behind the sun, hidden. The one moment we need data most will be completely blocked from view. This timing has Loeb particularly concerned. In his recent papers, he's calculated that this solar occultation period represents a perfect window for what he calls operations. If 3 I/ATLAS were conducting some kind of survey or mission, this hidden phase would provide ideal cover. 3 chances to solve this mystery. Then it's gone forever. The European Space Agency has even discussed the possibility of a rapid response mission, a probe that could intercept 3 I/ATLAS before it leaves the inner solar system. But with current technology, such a mission would take years to plan and execute. We'd miss this opportunity entirely. Consider the broader implications. If 3 I/ATLAS is natural, then interstellar objects can behave in ways that shatter our understanding of physics. Self-illuminating rocks that follow precision trajectories through multiple planetary encounters. That would require us to rewrite textbooks on celestial mechanics and cometary behavior. We'd need to explain how natural processes could create objects that generate their own light, navigate with apparent precision, and operate on timescales of millions of years. But if it's not natural, then someone sent it. Someone with technology advanced enough to power a probe for millions of years of interstellar travel. Someone who knows exactly how to study a solar system while staying hidden. This isn't science fiction. This is happening right now, above our heads. An object that might be the first confirmed piece of alien technology in human history, and most people don't even know it exists. The silence from major space agencies is telling. While amateur astronomers and independent researchers track 3 I/ATLAS's progress, official statements remain minimal. Press releases stick to safe terminology, the same pattern we've seen before. Whether it's a natural wonder or something far more profound, 3 I/ATLAS is proving that we're only beginning to understand what's possible out there. The next few months will determine if we're alone in the universe or if we've been visited by intelligence from the stars. The evidence is mounting, the silence is deafening, and time is running out. As 3I/ATLAS continues its journey through our solar system, every observation brings us closer to an answer that could change everything. But with each passing day, the window of opportunity grows smaller. Subscribe to Cosmic Void for updates as this story unfolds, because the sky was never empty, and now we finally see it. In Cosmos, we trust.